busy city at night. Millions of electric light bulbs help to brighten the darkness. The whole city seems to twinkle. Often, people are dazzled by the glow of these artificial lights. So, when they look upwards, into the night sky, they don't always see the natural lights, the stars. The closest many people get to the stars is their horoscopes in the newspapers. Your star sign might be Libra or Scorpio. It all depends on when you were born. According to these horoscopes, your life is supposed to be governed by the stars. Now, you may not think your star sign can affect your life one way or the other, but there is one star which does govern your life. Believe it or not, the sun is a star. And because we only see it in the daytime, it's easy to forget it's a star at all. It's much closer than the others, about 150 million kilometers away, and it's quite small as stars go. But compared with the Earth, it's big. In volume, it's about 1 million times larger. Because the sun's always there, we tend to take it for granted. Yet there's a lot more to find out, particularly if you're lucky enough to get to a telescope. But first, a warning. Never look at the sun with your naked eyes, and never ever look at it directly through a lens or a telescope. Normally, on a telescope like this, you'd look down the eyepiece, which is at the side at the far end. Except that in this case, it's hot enough at the eyepiece to light a cigarette, because this telescope is pointing directly at the sun. There's only one safe way to look at the sun, and that's to project it onto a screen some distance from the eyepiece. Now there's no danger because we don't have to look at it directly. Instead, we can view the projected image. And the first thing we see? The sun's got blotches, spots. And this special film shows us what happens to the sun over a period of 13 days. The spots move because the sun is spinning. Like all stars, the sun is a ball of hot gas, kept going by huge nuclear reactions at its center. The whole surface seems to boil and bubble. The sun really is very active. With giant jets of gas erupting into space. But remember, the sun is just one of many stars. It's only when the sun sets and our eyes get used to the darkness that we see these other stars. They're very much further away than the sun, and they exist in their thousands. People have always tried to make sense of the night sky. At first, they imagined patterns. Who would think that the stars could be joined up into groups? The groups were given names such as Pisces, the fish; Aquarius, the water carrier; Capricornus, the goat; Delphinus, the dolphin; Aquila the eagle. And in another part of the night sky, there is a very well-known group, the Plough. Two of its stars point to the North Star. The North Star is very important because it's always over the North Pole, and so it can be used for navigation at night. In different parts of the world, different travellers have imagined different shapes for the groups of stars. The plough is the name we give it in this country, an old horse-drawn plough. In America, people imagine a saucepan. They call it a dipper. The ancient Greeks thought the stars represented an animal, and they used some of the surrounding stars to form the shape of the Great Bear. Whole legends have grown up around what people thought they saw in the stars. There's a famous legend associated with this part of the winter sky. The ancient Greeks thought it was the home of their great hunter, Orion. They imagined Orion standing defiantly with his shield and club raised to defend himself against Taurus, a fearsome, raging bull charging down on Orion from out of the night sky. And wherever Orion goes, so do his ever-faithful companions, his two hunting dogs. Cowering with fear at Orion's feet is the hare, Orion's favourite prey. A river runs between Orion's feet. But remember, these are just legends. Orion the hunter only exists in people's imaginations. It's nothing more than a group of stars in a particular arrangement as seen from the Earth. Let's imagine we could travel way out into space, away from the Earth, and look at Orion from the side. The shape would change. Let's mark in the position of the Earth. The distance of the Earth to this star at the bottom, called Rigel, is 6,000 million kilometers. And if you think that's a long way, the most distant star, called Saiph, is 24,000 million kilometers away. The stars are all at different distances, and there are many other differences if you look much closer. Which is what star scientists, astronomers, have been doing here at Greenwich Observatory in London for hundreds of years. But to look more closely, you need the help of instruments. And by the way, that's me. My name's Heather Couper, and I'm one of the present-day astronomers who work at Greenwich. Like the astronomers before me, I use a telescope. This beautiful telescope was built over 100 years ago, and it's still going strong. Let's look at Orion again. The star on the bottom right is called Rigel. What can a telescope tell us about it? First, its colour. Rigel is a bluish-white star. Then, its size, 20 million kilometres across. Compare that with the Sun. Rigel is 15 times bigger. And although we think our Sun is hot with its surface temperature of 5,800 degrees centigrade, Rigel's surface is 15,000 degrees centigrade. Hot stars are blue and bright. Now if we look at another star in Orion, Betelgeuse, the telescope tells us a different story. Betelgeuse is a deep red-coloured star. And it's gigantic, 400 million kilometres across. How big is that? Well, here are 25 suns for comparison, and Betelgeuse still dwarfs them. Remember, the temperature of the sun was 5,800 degrees centigrade. Well, Betelgeuse, surprisingly perhaps, is cooler, just 3,000 degrees centigrade, and that's why it's a red colour. Stars can be so very different. To find out why, we need more information from more observations. Which is why we came here to Herstmonceux Castle in Sussex. Since the castle was taken over as the home of the Royal Observatory, some very uncastle-like structures have appeared on the horizon. Telescope domes. As the sun sets and the sky darkens, the night's work begins. Inside this dome is a bigger and better telescope. Because it's bigger, it's more powerful. It can gather in more of the light which comes from the distant stars. Many modern telescopes are fitted with electronic recorders, so you don't actually have to look through it. Instead, today's astronomers can view the night sky at any time at a computer terminal. Because the pictures are stored in the computer, it's now just a matter of asking for the picture you want. And the computer can help make things clearer. This is a view of Orion again. But now we are looking much closer at the spaces between the main stars. And you can see now that those spaces aren't even empty at all. The telescope shows up huge clouds of dust and gas, unbelievably thinly spread. The clouds are lit up by the light of the stars inside. These clouds are called nebulae. For instance, this is the Orion Nebula. And astronomers have found that these clouds of dust and gas are falling in on themselves. Over many millions of years, dust and gas comes together to form a star. New stars are found in nebulae. They're the places where stars are born. If a lot of dust and gas comes together, then the star that is born is big, hot and blue, like Rigel. Less dust and gas produces smaller, cooler, yellow stars, like our Sun. Astronomers think our Sun was born thousands of millions of years ago. And it's a relief to know that it should stay very much the way it is for thousands of millions of years to come. But ultimately, it will change. It will cool and grow to form a red giant. Then, like most stars, it will just fade away, but a few stars die in gigantic explosions. These explosions are called supernovae. This is the remains of a supernova that exploded almost 1,000 years ago. We know that because we can see that the gas is still moving outwards. Astronomers have found all this out about the stars just from the light coming from them. But some stars don't only give out light. They also give out radio signals, which can be detected with another kind of telescope, a radio telescope. This radio telescope is built on the site of an old railway line. It's made up not of one dish, but of several working together. The dishes are collecting radio signals coming in from space. And with the help of a computer, the signals can be turned into a radio map of the sky. The lines here show the strength of the signals. In turn, this can be changed into a radio picture. It's quite like what other astronomers see with their eyes through telescopes that gather light, except that's a pulsar, one of the new discoveries. It's a rapidly spinning star that gives out pulses of radio signals. A pulsar is what's sometimes left after a big star explodes. And here's another discovery. This fuzzy patch of light can be seen through a light-gathering telescope. And this is a map of the radio signals from the same part of the sky. It shows two huge clouds of gas. Where did they come from? Astronomers think that right in the middle, in the area marked by the box, there's a very powerful source of energy. Maybe it's a black hole. But what is it? How was it formed? These are just some of the questions that modern astronomers are trying to answer. And to look for those answers, astronomers use bigger and bigger telescopes, both light-gathering and radio, to scan the sky and look for new evidence from new observations. Modern telescopes are very big indeed. And the telescopes are even more complicated, and so they're even more expensive. This one has been built jointly between the United Kingdom and Australia. It's built in the middle of Australia because there the air is clean. In Europe, the air is mostly too polluted for decent observation of the night sky. To get completely clear of the polluted atmosphere, there's even a plan to launch a telescope into space. But professional astronomers aren't the only people who make new discoveries. Amateurs too have a vital role to play. These pupils are lucky. Their school has its own observatory. Yet anyone can observe. All you need is a simple telescope or even just a pair of binoculars. You never know. If you study the night sky hard enough, you might just discover something new. And even if you don't, there are still lots of fascinating and beautiful objects to be seen.
Can you see it?
How is it positioned?